Corrosion. Corrosion is a very costly thing that happens for us here around the world, but in the U.S. alone, it accounts for about $500 trillion annually. We just spent, $2 trillion on the bailout here for the coronavirus, so you can get an idea of how expensive corrosion really is. And the reason that this is a problem, bridges, roads, buildings, all sorts of things are made out of steel. Steel contains iron typically, and when that steel sees the oxygen in the atmosphere, the oxygen will react with that steel, react with that iron, and make iron-oxygen bonds. And when that happens, it cleaves the other iron-iron bonds that are in the steel, and you end up getting this flaking of the steel coming off. And so when you flake off one section, now you've created a new surface for fresh iron to react with the oxygen in the atmosphere, and then that peels off, and it keeps going and going until you end up with very little structural material left. If we were to use something like aluminum, that would be great because, one, aluminum is much more plentiful than iron is in the world. It's lighter than iron is. The problem is it doesn't have the same kind of strength as iron. But the other cool thing about aluminum is that it passivates. And what I mean by that is that when the aluminum reacts with the oxygen in the atmosphere, that oxide forms a coating over the aluminum, and it doesn't peel away from the rest of the aluminum underneath. And so you get a nice protective coating of aluminum over the rest of the material. And so we say that that passivates and protects the aluminum. Stainless steel can also be used. Stainless steel incorporates chromium, and typically what happens is that the chromium finds its way to the surface of that iron, and the chromium will also passivate, which means that it reacts with the oxygen in the atmosphere, but then it forms that nice thin coating of chromium oxide, and then the oxygen cannot get underneath that coating and react with other metals that are on the interior of that. We can also galvanize our materials, and so you've heard of galvanized nails before. That's simply a matter of putting a zinc coating over the iron, and because zinc will react with the oxygen faster than the iron will, then you get a zinc oxide coating. Again, that sort of passivates, not as well as aluminum or chromium, but it sort of passivates and protects the undercoating as well. We can also do what's called cathodic protection. And so if you could imagine at a gas station, they've got these big tanks that sit underground made out of steel. Those tanks will rust through, but what they typically do is they attach a wire to that tank, and a distance away they will place attached to that wire a chunk of zinc or a chunk of magnesium, and as the oxygen comes in and reacts with the iron and the steel and tries to pull the electrons away from the iron, then because magnesium or zinc are much more reactive, better reducing agents, then that iron or the magnesium will donate their electrons back to that iron and prevent the iron from rusting out. You'll also, if you've ever taken a hot water heater apart, you'll notice there's a huge rod that goes right through the middle of that hot water heater. That is a magnesium rod, and so it protects the canister of the hot water heater, because when you heat things up, they oxidize faster, and so you don't want your hot water heater leaking because of that. Last thing we can do is we can paint the surface, right? So we can paint the bridge or whatever. Paint protects the iron from reacting with the oxygen outside. We've gotten very good with paint over the years. We've now got paint which is referred to as self-healing paint. And so when you scratch your car or whatever, if your car is made out of steel, the paint will sort of start morphing and oozing into the place where the paint has been scratched off and reform a paint layer. So that's another way in which we can improve the corrosion problem that currently exists.